Strong electrolytes. In case of strong electrolytes, let us analyze how the molar conductivity behaves. This molar conductivity behaves in this manner, that is, molar conductivity that is represented by m delta m, that is equal to delta naught m. What is that? Molar conductivity at infinite dilution minus A into C power 1 by 2. C power 1 by 2. That is square root of C. Now, what do you mean by a strong electrolyte? Let us consider the electrolyte. Electrolyte is nothing but an acid or base or salt that can conduct electricity in molten form or in solution form. This can be classified into two: strong electrolyte, weak electrolyte. The strong electrolyte, they readily ionizes, completely ionizes, readily ionizes, completely ionizes. And the degree of dissociation is what? It means all molecules are totally dissociated. Whereas in this case, it is not readily, slowly. It is not completely, it is incomplete. And the degree of dissociation is less than 1. An example for this is HCl, NaOH, HNO3, and the NaCl, so acid, base, and salt. Whereas in this case, example, acetic acid, CH3, organic acids are generally weaker. So acetic acid, then ammonium hydroxide, and then you can take ammonium acetate also, that is CH3, COO, NH4, ammonium acetate. Now we are discussing about the conductivity of strong electrolyte. We have discussed the conductivity of weak electrolyte based on Cold-Rush law. Now let us consider this Debye-Huckel-Lonsager equation, that is nothing but the equation representing the strong electrolyte where the delta M is determined as the difference between the conductivity at infinite dilution and the product of A and its square root of concentration. Now let us see what is A. A is nothing but the slope here. For example, let us consider this graph. This is x-axis, y-axis, origin. In x-axis, let us consider the square root of C. That is also represented as C power 1 by 2, right? So it means what is the unit? Mole per liter whole power 1 by 2. Got it? Because it is square root. Okay. And now let us consider the lambda at certain concentration. Okay. And what is the unit here? Simon square centimeter per mole. And if it is to be indicated in terms of meter squared, what we are supposed to do? Multiply by 10 power minus 4. Why? Because 1 centimeter square is equal to 10 power minus 2 meter squared. Okay. sorry, 1 centimeter square, 1 centimeter is equal to 10 power minus 2 meter. So 1 centimeter square means 10 power minus 4. What is that? Meter square. Okay, so that you have to remember. Now let us go by centimeter square. So what is that? Simon. What do you mean by Simon? Ohm inverse. That is also represented as mho. Right. So this mho or Simon square centimeter per mole, and that being the unit of what is that? Lambda m. And how to represent the uh, molar conductivity at infinite dilution? You have to put naught. Okay. So what do you mean by this? Lambda naught m means what? Molar conductivity. Write down, write down. Molar conductivity at infinite dilution. Infinite dilution. Okay. Now here we have got the concentration units here. Now with the increase of this concentration, we are discussing about the decrease of concentration. What do you mean by that? Decrease of concentration means increasing the dilution. Do you understand this? When you decrease the concentration, what we are doing, that can be achieved only by dilution. So it means towards left, I am increasing the dilution. Do you understand? In opposite sense. Okay, that is decreasing the concentration. So when I decrease the concentration, the conductivity goes up like this. Okay, it increases, right? So this is called the infinity dilution. Infinite dilution. So here you have got certain slope. You will be having certain concentration. So what is the relevant molar conductivity at certain concentration? Okay. And another point. So for this concentration, it is now, it has come down, with the left, it decreases, right? Concentration decreases. It means dilution increases, right? And let me have another. So now you can observe there is an increase in the what? The equivalent conductance. I mean the molar conductivity. It increases, it goes on increasing. For this value, it is here. For this value, it has gone here. For this value, it has gone here. Let me say this is concentration 1, C1, C2, C3. And what about this? Lambda 1, lambda 2, lambda 3. Now I am in slowly decreasing the concentration. Almost it has got the negligible concentration of the solute means that is the infinite dilution. Do you understand this? So it means it will be in the highest order now. So that is why that is taken as lambda naught infinity. Okay. Molar conductivity at infinite dilution. So this part is molar molar conductivity at infinite dilution. And what about the other units? These are all molar conductivity at certain concentration. That is represented by lambda m. Okay. So it means there is a slope here. Okay. There is a slope. Okay. And this slope, what do you mean by slope? Dy by dx. This is y. This is x. So let us take infinitesimal small one. So dy by dx. So this value of dy by dx, that is nothing but the slope. And that slope is a negative slope, is it not? So that is indicated as A here. And that is why we have put minus A. So negative slope. It is coming down, right? And when you look at this equation, it is all almost equal to y is equal to, that is C plus mx, is it not? Okay. It's a very famous equation, is it not? Y is equal to mx plus c, where m is the slope, x is the variable, y is another variable. What about this c? So it means that is the what. So in that case, the y, I mean the a is a very important value that represents the what? The slope. Okay. Is it clear now? So we obtain a straight line, an equation of straight line here, and this lambda m value increases with the dilution. Okay. When I say increasing the dilution, I am decreasing the concentration. But you have to use the word decreasing the, I mean increasing the dilution. Okay. By adding more amount of salt, the concentration is brought down. So with the increase of dilution, the value of molar conductivity increases and it reaches the peak value, and that is called the lambda m at, I mean naught. Okay. So the here the slope is equal to what is that? Minus a. And this a depends on the temperature, the type of electrolyte, and also the charges of the cation and the anion. For example, when you've got NaCl and NaCaCl2, then MgSO4, that will be different. Okay. It depends on the number of ions also. So you look at your example number 3.6, where they are given the molar conductivity value and the concentration value. So what you are supposed to do, you have to draw a plot. How you can draw the plot? No, I got book. Please refer to that. Yeah. So they are given the concentration. In example, look at example 3.6. Now I'm talking about the example sum. They are given the molar conductivity of KCl solution at different concentration at the 298 Kelvin. You can note down. So they are given the values, that is C per mole per C. This is a concentration and that is given in terms of mole. If you put like this, C with the unit mole per liter. So this is the concentration unit they are given. And here they are given the lambda at, I mean lambda at certain concentration. And its value given is, I mean unit Simon square centimeter then per mole. Okay. Instead of putting square, I mean bracket, the unit within the bracket, they have put the slash. Okay, in your book. It should be taken as within bracket. So this is a concentration given in mole per liter. This is a molar conductivity value in terms of what? Simon square centimeter mole inverse. Got it? Now they have got different value like 0.00198 concentration and here 148.61 and they are given 0.000309 value. Then the value is 148.29 and again 0.000521. The value here is 147.81 and again 0.0009 then 89 and for which the conductivity value is 147.09. Okay. Now, what they are asked, show that plot between lambda m and the c square root 2 is a straight line. That is the question asked. So, if you are given some graph sheet, you are supposed to use the graph sheet. Okay. So, it means um, show that, take down, show that the plot drawn between lambda m and c power 1 by 2 is a straight line. And not only that, they ask you to determine the value of lambda naught m and a for KCL. So this is the problem. Now what we are supposed to do? Solution. You have to find out the square root value because we can obtain the graph only with c power 1 by 2. That is square root of c. And then here you have to put lambda m value. Okay. So now what we are supposed to do? You have to find out the square root of c, for which what is the unit? Mole per liter power 1 by 2. Okay. So this is the value, and the respective value should be noted down for lambda m. That is given in Simon square centimeter mole inverse. So you have to find out the square root of this one. So this can be given as what? You can take 1.98 into 10 power minus 4, right? Take down. 0.0001 means take it as a square root of, I mean, in this way. And what about the next value here? 3.09 into 10 power minus 4, right? And this one 5.21 into 10 power minus 4. This one 9.89 into 10 power minus 4. So you know very well, for 10 power minus 4, the square root is 10 power minus 2. So the remaining is 1.98. So find out the square root of 1.98. Take the calculator and do it. 1.98. Tell me. Take the square root of 1.98. 0.98 square root of 1.407, right? So you can write as 1.407, right? 1.407, which is nothing but how to write here? 0.0014 and not 00. 0.01407. That's all. So this is given in. So likewise, we have to find out the rest of the values. Can you do that? Yes. Right. For 3.09. It is 3.0 means what? How much? 1.75. 1.758 into 10 power minus 2. It means 0.01758. Similarly, for the next value, 521. 5.21. How much? 2.2. 2.28 into 10 power minus 2. So it means 0.0228. And next value, 83 m. Next, 9.989. How much? 0. That is 3.145 into 10 power minus 2. It means 0.03145, right? And you can repeat the same value. There is no change in there. Okay. So you can do this 148.61, 148.29, 147.81, 147.09. Now what you are supposed to do, you can take the values like this and put it in the graph. So this is y-axis, this is x-axis. So When you do all these things, you are able to get a slope like this by getting the lines here. Are you able to follow? And you have to take a small value here, small value. Okay. So a small value here, dy, and this is dx. Okay. So the difference in the, what is that? Y value, y2 minus y2. Okay. So let me call this one as y2, y1. What is this? X1, x2. So we know that the slope m is nothing but, what is that? Y2 minus y1 divided by x2 minus x1. Okay, and that is found to be, you can find out because you got the values here. So mark it and find out the value. You have to do practically like this. Okay, and this is y1, this is y2, this is x1, this is x2. So the value, and it is found to be, in this case, 87.47. Okay, take down 87.47. 87.47. So this is the value 46. This is the value of the slope. Okay. Now from this equation, you should be able to give the answer also. For example, in this case, you have the value lambda. What is the, what they have asked? Lambda not m minus, what is that? A into root c value. Is it not? Is equal to lambda m at certain concentration. Okay, so you can select certain concentration. For example, you can take this concentration 1.98, and you got already this root C value. So for this root C value, this is the lambda m. Okay, now you have got the slope. Now you are able to get the, now A, you already calculated. Got it? You already calculated. Root C, we are going to take the concentration. And for the respective value, you have got already M. By knowing all this value, you can find out lambda not M can be determined. Okay, so they may give a question. If they give the question, you have to get the graph and do it, right? So we continue the next class.